So this is my Biology 12 intended learning outcomes summaries. In this video, we are going to be covering A2, and for section A2, we are going to be doing the scientific method. Question number 1. What is the scientific method? As we all know, when it comes to the world, many people had many questions. Oftentimes, the people who asked these questions wanted to look for answers. Plenty of them had ideas, but lacked any actual proof. So in order to root out the fantastical ideas from becoming true, and to make sure that the ones that weren't true became known as false, they created the scientific method. Next question.
What are the parts of the scientific method?
The parts of the scientific method are fairly straightforward. As anyone would think, it all begins with an observation. The observation is where a person will observe or see something happening and then wonder why. The example I've given here is they see the flower growing in the sunlight, but when the sun is taken away, it will not grow. That leads us straight to our next step, the question. Here we see our little scientist guy, he is questioning what makes the flower grow. The next step is to create a hypothesis. Now, this needs to be broken down into a couple steps, because the first step to a hypothesis is where you come up with an idea of what you think the reason is. Here, you can see our little scientist guy thinking the sun must be what makes the flower grow. The next step in a hypothesis is you need to come up with a testable prediction. This is basically how you write your hypothesis. A very simple way to remember it is if what you think is going to happen, then what you believe will happen. So basically, like, using the example we've been following so far, our testable prediction would be if the flower is planted in the sun, then it will be able to grow. Once you have your hypothesis and testable prediction, you can begin the testing. Testing is done through using controlled experiments. When conducting a controlled experiment, you'll have minimum 2 groups. One group will be your experimental. other, your control group. The purpose of the control group is basically to have a basis of observation so that you can know if your experimental variable is doing anything. The experimental variable is the item you are testing. To refer back to our original example of the flower in sunlight, we will design a little experiment. To refer back to our original idea of the flower in the sunlight growing better than a flower with no sunlight, the experimental variable belongs in the experimental group, and in this case it is the sun, because we believe that the sun makes the flower grow. The control group is lacking the sun. Now, when you are doing a test with an experimental and a control group, there are a couple of rules you need to take note of. Other than the experimental variable, light, dark, all your other components have to be the same. In this case, you would have to have the same type of soil, the same grass, the same flower, because flowers grow differently in different areas. Some like light, some don't. You have to make sure all of those components are the same and they're watered the same amount and everything, to make sure that the thing you are testing is truly the sun. Once you've finished your experiment, or more so as you're doing your experiment, your next step is to be collecting your data. Data is always recorded in a graph or chart. When you're collecting data, there are 3 different types of graphs that you can use: pie charts, line graphs, and bar graphs. But most commonly you're going to get line graphs and bar graphs. When creating your graph, time elapsed, or the time elapsed, or the test number, or whatever it is, goes on the x-axis, whereas the independent variable always goes upon the y-axis. So for our example, it would be growth is what we're measuring, and time. So over time, the amount it's grown. We will use orange as the with sun line and purple as the no sun line. So say orange went like that, whereas purple went like that. Just hypothetically speaking, you would have actual numbers. Your next step would be to revisit your hypothesis. Was it right or was it wrong? If you were wrong, you might want to go back a couple steps, form new tests, and carry on from there. However, if you were right, you get to move to the next step. Your next step is your conclusion, which is basically what did the testing prove? What happened? And once your conclusion is complete, you get to create your theory. Your theory is basically stating what happened and making it real in the eyes of the scientific world. And last but not least, why? Why is this so important? The scientific method is important to us for a lot of reasons, but mostly so that people, they can't just create random ideas and put them out there as fact. It gives us a basis for judging what's true and what's make believe. It gives us tangible physical proof.